Welcome to our next lecture where we're going to look at case control studies. You'll see the objectives for case control studies are here. Again, they're very similar objectives to what we've seen in the cohort studies lecture, except specific to case control studies. And once again, just highlighting that in our hierarchy of evidence, this is where the case control studies sits. You can refer back to our introductory lecture where we looked at all the study designs together for the more detailed definition of a case control study. But remember that generally when we are looking at a case control study, we note that outcome ascertainment occurs before exposure measurement. What does that mean? Well, it means that subjects are recruited on the basis of exposure. So we get a group of people who have a disease, we get a group of people without the disease, and then we can look back in time and compare the frequency of a particular exposure. What does that look like pictorially? We see here from our population, we can select a group of people with the disease and without the disease, and then we can look back in time to analyse what exposures were there. So we can analyse for our group of people with the outcome of interest, whether or not they had an exposure, and likewise of the people who do not have the outcome of interest, whether or not they have an exposure. And we can compare this frequency with this frequency. Let's now look at some important design elements for a case control study, and we're going to start with case selection. Ideally, for a case control study, cases, those with the disease, are going to be incident cases. This is because the risk factors for a disease are a combination of whether you have the disease or not, the presence or absence of the disease, plus the duration of the disease, which is how long people have the disease before they either recover or die, etc. Because prevalence is mathematically linked to incidence and duration, so we've seen previously the prevalence is equal to or is approximately equal to incidence times duration. Because there's a link between those, it's difficult to separate out the impact that the duration of the disease has on the case. So as people go on, what they look like might be very different if they're 20 years down the road of their disease compared to a newly diagnosed person with the disease. So ideally, to have a very good idea about what's going on in that case, we get incident cases. However, you can actually have prevalent cases. So you can enroll prevalent cases, people who have existing cases of the disease. This really only holds up for very rare diseases, and it looks very much then like a cross-sectional study. It has the possible problem of trying to determine the clear time sequence between the exposure-disease relationship, and we also see that we might have a survival bias, meaning that if you enroll prevalent cases, you may miss all those really severe cases who have died before you can recruit, which is the duration component of it that we talked about before. Other important features for a case selection, not surprisingly, are going to be the case definition. So we need to be very clear about the case definition, and you need to have a very objective way of measuring that. All of the cases, and actually the controls for that matter, need to have potential to be exposed to the risk factor. So you cannot select, if you're interested in the risk factor of deployment overseas in a war, you can't select someone who has not been deployed overseas, for example. So you might think, you might be asking, does deployment overseas in a war lead to increased depression? Well, you can pick people on the number of depression, but they can only be included if they've had actually the possibility of being exposed to that risk factor. In that case, you might pick armed services people. Move on to looking at the importance of the control selection. So the controls that are selected must be as similar as possible to the cases, except that they don't have the disease, which is why obviously that they're selected as a control. And it's really crucial to the success of the study. Ideally, the control group should be a random sample of all non-diseased or people who don't have the outcome of interest drawn from the same population as the cases, but have the same potential for the exposure as the cases have had. So that's the ideal example. Some of the approaches that we see to control selection are listed here. You can have a population approach, which sees both the cases and controls randomly drawn from this specific population of interest. There's the cohort approach, which is essentially a nested case control study, and we'll look at that at the end. You can have hospital and community controls. This approach occurs in situations where population and cohort selection is not possible, but produces controls that appear similar to the case group. Hospital controls are controls who are selected from the same cases as the hospitals, except they are in the hospital for a different outcome. This type of control selection is more prone to bias because the hospital sample are inevitably biased just by the fact that they're in hospital. The community controls are selected from a community that surrounds the hospital, again is prone to a selection bias, as hospitals often do not exclusively draw from the surrounding community. You might say, for example, Monash Medical Centre, you might want to select from around Monash Medical Centre, but people from all over East Victoria could potentially end up in Monash Medical Centre, but you've not selected from anyone who might come to Monash Medical Centre from a rural background, for example. Case control groups can also have multiple groups, multiple controls. So that's where we see for every case, there is more than one control, and it improves the ability to determine a difference in the risk profile. We get an improvement for each additional control per case up to about 3 or 4, and then we see that there's no improvement in the ability to determine the difference between the two groups. Matching is a very commonly used control selection technique where it's not just using case control studies, of course, but we match for particular types of characteristics which may be strongly related to the outcome. An example is we match the cases and controls for age or sex. The idea behind this is to reduce the variation between the case and control groups in all but the risk factors of interest. However, again, the more you want to match, the harder it is to get a good match between the case and control. And a negative control down the bottom is a control that has no comorbidity. It is a more pure definition of what that control might be. We've looked at case selection, which includes our outcome measurement. Now, also, we need to be very clear about our exposure measurement. So we've got our group of people. We want to go and look at what exposures they were subjected to. Just as with the outcome ascertainment, we need to make sure that there's a clear and objective process to measure the exposure. The most accurate way of assessing exposure is through thoroughly completed medical or pharmaceutical records or stored samples from the laboratory analysis. When these sources are unavailable, measurement of exposure often occurs through the questioning of cases and controls or their appropriate proxies. And in that case, we want a good interviewer and a good questionnaire. This process, you can see, is inherently prone to bias, including a recall bias and a record bias, and we will look at these types of bias a bit later on. But one of the great strengths of a case control study is that because patients are selected on the presence or absence of an outcome of interest, we can look for multiple exposures. So we might select everyone who has lung cancer, and then we can look for multiple exposures. So we might look at exposures to smoking, we might look at exposures to bacteria, we might look at exposures to pollution, air pollution, we might look at work exposures such as asbestos. So you can look at multiple exposures, not just the one. We've already looked at one of the advantages of the case control study, which was the ability to assess multiple exposures. Some of the other advantages are that they're good for rare outcomes, obviously, because you can run around and find everyone with this rare outcome, collect them together, and then look at what exposures may have been present. And common exposures that will crop up reasonably frequently that you can pick up. They are happily relatively fast and relatively inexpensive. We've already looked at the control selection and the difficulties that that has in terms of being able to introduce bias into the study. And they're not good for measurements of rare exposures. If the exposure is too rare, it's unlikely that we will be able to detect it from our original outcome, our cases and controls. Also note that the advantages and disadvantages of a case control study include the same advantages and disadvantages that are listed against the retrospective cohort study. And when you look at the schematics, you can see that they actually do look relatively similar. We talked very early on about the selection of cases, and one of them was to use a cohort selection, in which case we ended up with a nested case control study. Basically, a nested case control study is a type of case control study that draws its cases and controls from a cohort population that has been followed for a period of time. From the schematic here, we see that they select an original cohort population, just as in for a cohort study. They follow up after a period of time. Some develop the disease and these guys become cases. The rest remain disease-free and these become controls. And then they may go back and use previously collected data and or obtain additional measurements of exposure from records or specimens that are available to determine what was different about this group and that group. I've just listed here a table that provides a summary comparison between the main characteristic features of a cohort and a case control study, so that you can see when you would use each of the different studies, the circumstances which you do, and the type of information that they can elicit. So that's the end of the case control lecture. We're going to move on in the next lecture to look at how we actually measure the strength of the association that a case control study will put up. So we'll look at the last of the measures of association, which is odds ratio. Thanks very much.